Hey everyone, it is now question from Cambridge International A-Level Physics 9702, paper 22 from February March 2016, and this is question number 2, and we can see it is of 2 pages in left and right. They are distinct pages, and in this video we are going to solve this question number 2. Now let's go through the first page. And in first page, question number 2a, question is define acceleration. As we all know that acceleration is the rate of change of velocity, so we can write here the rate of change of velocity, or we also can write change in velocity by change in time. In b, a question is that a ball is kicked from horizontal ground towards the top of the vertical wall as shown in figure 2.1. This is figure 2.1. The horizontal distance between the initial position of the ball and the base of the wall is 24 meter. The horizontal displacement is 24 meter, where the ball is kicked. Initial velocity b at angle 28 degree to the horizontal. This is the initial velocity b, and the angle to the horizontal is 28 degree. The ball hits the top of the wall after a time of 1.5 seconds. Air resistance is assumed to be negligible. Calculate the horizontal component by x of the velocity of ball. We have to find the horizontal component of the initial velocity, and for horizontal component of ball bx, we already have the time taken is equals to 1.5 seconds, and this displacement is 24 meter. Horizontal displacement is 24 meter. So we can use the formula that the displacement is equals to velocity times time taken. Then displacement equals to velocity times time taken, and velocity is equals to 16 meter per second. So the initial horizontal component, or the horizontal component, is same in any point. So the horizontal component of ball's velocity is 16 meter per second. We found the answer 16 meter per second, and in CAIE examination we have to fill this answer in this space provided. In II, question II, show that the initial vertical component of the velocity of ball is 8.5 meter per second. Now we have to show that the initial vertical component of By of the ball is 8.5 meter per second, and we already have theta equals to 28 degree to the horizontal, or By, or the vertical component of the ball's velocity, initial ball's velocity, is equals to b sine of theta. The vertical component is b sine of theta, and bc and b cos theta equals to 16 meter per second. We already got the b cos theta equals to 16 meter per second. Now b sin theta equals to b sin theta dot cos theta by cos theta. Cos theta cancels cos theta, so we can write b sin theta equals to cos theta dot sin theta dot b by cos theta, which is equals to 16. We got b cos theta, b cos theta equals to 16 times sin theta by cos theta meter per second, or by equals to 16 times 10/28. This sin theta by cos theta equals to sin 28, so 16 times 10/28 meter per second, which is equals to 8.5 meter per second. Then we got the solution for this too. For III, calculate the time taken for the ball to reach the maximum height above the ground. We have to find the maximum. We have to find the time taken for the ball to reach its maximum height of the ground. Time taken to reach it to the maximum. Now we know that at maximum height, the vertical velocity is equals to 0. Then v or vertical velocity equals to ub plus av times t, with is v equals to u plus at, or 0 equals to 8.5 minus 9.81 times t. 8.5 is initial vertical velocity. 8.5 from II, get the solution for t, which is equals to 8.5 by 9.81 seconds, and t is 0.866 seconds. It also must be written here, where the space is provided, 0.866 seconds, and it's not necessary to write the unit, as unit is already given mentioned there, and we must be careful about the. Now let's move to the second page. Question IV. The ball is kicked at time t equals to 0. On figure 2.2, sketch the variation with the time t of the particle component Py of the velocity of ball until it hits the wall. It may assume that the velocity is positive when it is in upward direction. We have to assume that the velocity in upward direction is positive, and we have to draw the line in the graph for the vertical component of the velocity. And we all at time t equals to 0, we have calculated the vertical velocity equals to 8.5, so it must be started from 8.5, and vertical velocity at maximum height is equals to 0, and the vertical velocity must be equals to 0 at 0.866 seconds, as we have already calculated in question number III. Then the line should be started from 8.5, touching 0.866, and we only have to draw the line till 1.5 seconds. So the line looks like this. Now in C, I use the information in B to determine the maximum height of the ball above the ground. We have to find the maximum height above the ground. Now the maximum height is given this by this area, is the area under the velocity time graphs gives the displacement, and this is the upward displacement word. Now maximum height equals to area under the line to the time axis, area under the line to the time axis, which is equals to 1 by 2. It is a triangle, so 1 by 2 times 8.5 times 0.866 meter, which is equals to 3.66 meter. So it has maximum height of 3.66 meter. Now in II, the maximum gravitational potential energy of the ball above the ground is 22 joule. Calculate the mass of the ball. And in II, it is given that the maximum gravitational potential energy of ball above the ground is 22 joule, and we all know that the maximum gravitational potential energy is at the maximum height. So at the maximum height, its gravitational potential energy is um, mgh, and according to question, mgh equals to 22 joule, or 22 joule equals to m times 9.81 times 3.66 height, and 9.81 is acceleration due to gravity. From this we got mass equals to 0.612 kg. filling it here 0.61 kg. In D, a ball of greater mass is kicked with the same velocity as the ball in B. State and explain the effect, if any, of increased mass on the maximum height reached by the ball. Air resistance is assumed to be negligible. And the question asks us that the ball is kicked with the same velocity but have the greater mass, and can it affect the maximum height? Obviously not. It can never affect the maximum height, as the maximum height is depend upon the two factors: acceleration due to gravity and the initial velocity. So maximum height is not affected by the change in mass. The answer is no, the acceleration remains unchanged and mass does not have any effect on it, so the maximum height can't increase.